Those of you that took the fractal course remember StarLogo. It's recursive power mixed programming, recursive similarity fractals like the Koch curve. Very, very simple with nice, short, compact code. This time I want to use StarLogo to model a physical process called diffusion. We'll start with creating 4,000 turtles. Each turtle will represent a particle, a molecule. In this case, a molecule of food coloring, for example. And the 4,000 turtles, each of which will follow in parallel this simple program called to move. It will pick for each turtle a right turn from 0 to 360 degrees. Random 360 will pick a number from 0 to 360. Once that turn angle has been picked, it then moves forward one step and then calls itself again. So it moves and repeats the process until we hit the stop button up here. So to model the diffusion, I'm going to, in a second, just hit the diffusion button here. All 4,000 particles start at the origin, and things happen fairly quickly, so you need to kind of watch fairly closely. So I'll hit the diff button and get things moving here. We see even though they all started at the same point, very quickly we have a circular pattern with some outliers where we can see the individual particles that are way out there on the outlier kind of edges. This process, known as diffusion, is a example of what happens when you have 4,000 random walks all happening at the same time. Now, we can mimic or we can model this in the physical world, in the real world, with a bit of red food coloring, and that will be the topic of the activity called diffusion rings.